Welcome back to the last lesson in Chapter 10 of the Pearson Geometry video series. Lesson 10.5 is an exploration of secants and segments. Secants are the lines that pass through a circle, intersecting at 2 points. Segments are the spaces in between an arc and a chord, like right here. So let's take a look at the theorems. An angle formed by two secants, like angle 1, is half the measure of the intercepted arcs. Okay, so the intercepted arcs from these two secants, so from this angle, it's going to be this arc X and this arc Y. So in order to figure out the angle measure, we would add these together and take half. All right, theorem 1011 says an angle formed outside the circle by two secants is half the difference of the intercepted arcs. So angle A and angle B are the intercepted arcs. So we would take arc A and arc B. So we would take arc B minus arc A and take half. And that's going to be the angle measure for angle 1. And last but not least, theorem 1012, which has several cases. This has to do with segments. And one case is when the two segments form angles inside the circle, and the other case is when the two secants form an angle outside the circle. So when the two secants are inside the circle and the angle is formed inside the circle, then we're going to take A times B and set it equal to C times D. And when the angle is the vertex of the angle is outside the circle, then it's going to be N times M plus N equals Q times P plus Q. And it's easier to think of it as the outside times the outside plus the inside. Okay, let's take a look at some examples. In this first example, we want to find the measure of ABD. So we're looking for this angle measure right here. Okay, and we know that this arc and this arc, we are going to subtract them and take half the difference of the intercepted arcs. So we have 151, and then we have 139 over here. So this is what's left after we take them away from 360. So if we add 151 plus 139, we're going to get 290. And then when we take 360 minus 290, that's going to leave us with 70 degrees. So this arc is 70 degrees. So we want 1/2 of 151 minus 70, which is 151 minus 70 is going to be 81. And so 1/2 of 81 is going to be 40.5. So the measure of ABD is 40.5 degrees. Okay, next example. In this one, we want to find the arc WZ, which is right here. Okay, so normally we'd be looking for the angle, and we would add the two arcs, the intercepted arcs, and take half. So let's go ahead and set that up. We're going to call this X. So we're going to say 74 plus X, because we're adding those together, and divided by 2 is going to be this interior angle. So that's going to be equal to 107. Okay, so if we go ahead and multiply both sides by 2, we're going to get 74 plus X is equal to 214. Okay, so we can subtract 74 from both sides, and X is going to be equal to 214. So the measure of arc WZ is going to be 214 degrees. Okay, last example on this page. So we want to know what the measure of arc LM is, which is right here. Okay, so we know that the difference between, or half the difference between these two arcs gives us our angle measure. So we're going to set it up with what we know. So 6x minus 3x is going to be 3x. And 6 minus a minus 5 is going to be 11. So we're going to have 3x plus 11. And let's see. That's going to be equal to, or rather 1/2 of that is going to be equal to 34. So let's start by doubling that to get rid of our 1/2. So we can say that 3x plus 11 is actually equal to 68. And then when we subtract 11, we get 57. And when we divide that by 3, we are going to get 19. So we know that x is equal to 19. All right, we still haven't figured out what the arc measure of LM is, so we're going to have to plug these back in. So we want 6 times 19 plus 6, I don't know why I added that, equals 120. So the measure of arc LM is 120 degrees. Okay, let's flip this over, because on the other side, we can organize all of these different formulas with a graphic organizer that makes this a little easier to understand, and this is probably what you're going to use as you work through your Pearson problems. So we are measuring angles and we are measuring segments. We are measuring sometimes when the vertex of the angle is inside the circle, and we are finding measures when the vertex is outside the circle. Okay, so depending on what you're looking for, you have a different formula. So if you're looking for an angle measure and your vertex is inside the circle, then this is your formula. The measure of this angle 1 is 1/2 the sum of the intercepted arcs. Okay, if your vertex is outside the angle, then your angle measure is going to be 1/2 the difference of the larger arc minus the smaller one, or the farther one minus the closer one. And it doesn't matter what it looks like. In this case, it's this arc minus this one. In this case, it's this arc minus this one. And in this case, it's this arc minus this one. All right, now let's say we're looking for segment measures. In this case, the vertex of our angle is inside the circle, so we're going to say WX is equal to YZ. In these two examples, our vertex is outside the angle, so for this one, we're going to say A times A plus B equals C times C plus D. So the outside equals this, or the outside times the outside plus the inside. Okay, when we don't have two measures, okay, because it's a tangent instead of a secant, then it's going to be T times T plus U equals V squared. Okay, we're just going to use this one. So let's take a look at a few more examples and see how these work. Okay, so for the first one, we're looking for an angle measure. So we're using this one right here because our angles are inside the circle. So we want the measure of angle BEC. So we're looking for this one right here. So it's going to be 1/2 the sum of these two intercepted arcs. So we're looking at 60 plus 86, which equals 146. And then half of 146 is equal to 73. So answer of measure of angle BEC is going to be 73 degrees. Okay, let's take a look at example 2. So we want to find the measure of PQR, so that's this right here. So we know that 1/2 the difference of these two arcs is going to give us our angle measure. So we know this one is 125. We don't know what this one is, but we can find it. All we have to do is take 360 minus 125. And when we do that, we're going to get 235. So we want 1/2 of 235 minus 125. And we are going to end up with 1/2 of 110, which equals 55, which means that the measure of angle PQR is equal to 55 degrees. All right, example 3. For example 3, we are finding GF, so we're going to label that X. Okay, so this is a vertex outside, but it's with a tangent, so we're looking at this one. Let's see, this one right here. So we want 8 times x plus 8, and that's going to be set equal to, since this is a tangent, 12 squared. Okay, so we have 8x plus 64 equals, do you remember 12 squared? Quick, quick, quick. 144. Good. Okay, so then we're going to subtract 64 from both sides, and we're going to end up with 8x equals 80, or x equals 10, and so FG is equal to 10. See, that's not so hard, is it? Okay, example 4. Same kind of problem. We want LM, so let's call this X. And this time we have 2 secants. So we're going to say 6 times x plus 6 is equal to 7 times 9 plus 7. It doesn't matter what order these are in, as long as you have the outside times the outside plus the inside. Or you can do the outside times the inside plus the outside, but you're using them both inside the parentheses. Okay, so let's go ahead and distribute, and we are going to get, let's see, 9 plus 7 is 16. So we've got 7 times 16 is equal to 6x plus 36. And 7 times 16 is 112. So let's subtract 36. And we're going to get 76 equals 6x. I don't know why I switched them. So x is going to be about 12.7. 12.66666, 12 and 2/3, something like that. But we're going to round it. So let's go ahead and make this an about symbol. All right, so x is about 12.7. Okay, let's see, example 5. We want to find BC, so let's call this x. Okay, so we can say 2 times 2 plus x equals 4 squared, because this is a tangent. If it went through, we would use both of these, but since it's a tangent, we're just going to use this one. So 2 times 2 plus x is equal to 4 squared. So we get 2x plus 4 is equal to 16, and I just distributed and moved them around a little bit because I like the x first. Subtract 4 from both sides, and 2x equals 12, which means that BC is equal to 6. Okay, now we want to find EF. EF is right here. Let's call this one Y, so that we don't get it confused with this one up here. So we're using this one and this one. And this is a tangent out here. So we're going to say 4 times 4 plus 5 is equal to y squared. Okay, so this is 9. So 4 times 9 equals y squared, or 36 equals y squared, which means that EF is equal to 6. And you know that the square root of 36 is actually positive and negative 6, but when we're talking usually in geometry, because we have distances, then we're only going to use the positive number. All right, we have one more. Example 6. So higher order thinking. That means a little bit more challenging than the others. So we have two tangents right here, and we want to know what the measure of ADC is. Okay, so we're looking at this one. So since we have these two arcs and our angle is outside the circle, then we want 1/2 the difference between this one and this one. Okay, and we don't know what either one of those are. But if we think back about what we did in lesson 10.4 with angles and arcs and chords, we know that this inscribed angle is 72 degrees, which means that this arc right here is twice that. So this arc is 144 degrees. So if we know that this arc is 144 degrees, then we can figure out what the major arc ABC is by subtracting 144 from 360. So 360 minus 144 is going to leave us with 216 degrees. Okay, so this arc is 216 degrees. So we want the difference between 216 and 144. And then we want half of that. So we want 1/2 of 216 minus 144, which is going to be approximately 72. Half of 72 is 36. So the measure of angle ADC is going to be 70 or 36 degrees. All right, and that's all we have for now, but that should be enough. And the next time that we meet will be in chapter 11. See ya.